Hello and welcome to Diplomatic Derivatives. In today's video, we're going to move on to another optional of CSS, that is applied mathematics. Now, pure mathematics is already being started in the previous series of lectures. So we started with the group theory, that's part of pure mathematics, and we will be continuing those videos as well. So in these series of lectures, we're going to focus specifically on applied mathematics. Now, the applied mathematics starts with the first section being vector algebra, in which we're going to see the basic concepts of vectors. We also will be focusing on scalar and vector products, differential operators, vector integrals, and vector theorems. So these are all the topics that will be covered in the future videos, and we will be talking about the rest of the sections in the syllabus as well. So let's begin with the very first topic of vector algebra, that is the basic concepts. Now, just to look at the agenda that we are going to deal with, the topic of vector algebra from the very beginning. Now, we will be dividing the entire series of vector algebra into 5 portions. In the first portion, we are going to talk about the basic concepts. Now, the basic concepts start with vector itself, and in that we'll be talking about the magnitude and direction. Next, we'll be talking about the position vector. We move on to vector addition and subtraction. That will also include scalar multiplication, because we know that there are two concepts, as we studied in high school physics as well. We had scalar and vector quantities. So applied mathematics specifically focuses on the vector part of it, and we'll be seeing scalar multiplication as part of the vector algebra. Also, we will talk about unit vectors, and we'll be talking about linear combination of vectors. So these are all the topics that will be covered in the vector algebra portion as basics. Okay. First off, we're going to start with what is a vector. Now, a vector is a quantity that has both a magnitude, that is how much, and a direction, that is in which way. So when we talk about scalar and vector, scalar is something which is only having a magnitude. It does not have a direction. Vector is a quantity that has both a magnitude and direction. If you look at the image over here, you will see that this is a vector. It has a magnitude and it also has a direction. Okay. This is in contrast to a scalar, which has only magnitude and no direction. For example, temperature. Temperature is, let's suppose 45 degrees, let's suppose 2 degrees. These are all magnitudes. There are no directions. Mass, something in kilograms or grams, speed, meter per second, all of these things are having only magnitude and no direction. Okay. Next, we're going to see some examples of vectors. So first one is displacement. Now displacement, let's suppose 5 kilometers to the north. So you're moving, displacement is a movement towards a direction, right? So we see on the Cartesian plane, we have north and 5 kilometers. So it has a magnitude, which is 5, direction is north. Okay. Then we have velocity, 60 meters per second east. So it has a magnitude 60 and direction is towards the east. Then we have force. Force is also having a direction. It's applied in a particular direction. So for example, if you're pushing a chair, right? So you're applying a force in a certain direction, right? So this is 10 newtons downwards. This is the unit for force. So 10 Newton is the magnitude and direction is downwards. So if you're pushing something downwards, you're applying a force in the downward direction. So that is 10 Newton downwards as an example. Now we're going to see the two things in detail, that is magnitude and direction. These are the two things that define a vector. A vector, again, a vector is a quantity that has magnitude and direction. So magnitude of a vector is the length of a magnitude or length of a vector tells us how big the vector is. It is always a non-negative scalar. So magnitude has to be non-negative. Okay, it's always a value. It's always a positive value. Now, in terms of mathematical representation, we see for a vector A in 2D or 3D. So we're always going to see things in either 2D or 3D. These are the two representations. Okay, now we'll see how that is represented. For a vector A, let's suppose we are having a 2D representation. So a 2D vector which will be drawn in an x and y coordinate, right? So just to draw here, we will have these coordinates. So we have x and we have y. Okay, this is a 2D plane. Now if we are also having another coordinate which is z, so it becomes 3D. Okay, so if we just have x and y, it's 2D, and if we have another one, z, it's 3D. Okay, in 2D representation, vector A, it is represented with the alphabet with an arrow on top. Okay, so this is arrow on top of A. All right, so vector A is equal to a1i plus a2j. Now this is known as a representation of vector. You have already done this in high school, so I will just make you revise the details over here, not going into too much depth. We will just understand in very basic manner. We have a1i, I is a unit vector, and it represents the value on the x-axis. Okay, and a2j, j is representation unit vector for the y-axis. So this is the value for y. So if you're having this first value a1i, you know that it is going to be pointed out on the y-axis, sorry, x-axis, and a2j, so this will be found on the y-axis. So if you have a1, let's suppose a1 comes over here and a2 comes over here on the y-axis. So when you join these parts, okay, this is a point that you get, and this is the vector from the origin. Okay, so you're having it from the origin. All right, so that's just an example of how you do it. So you have a1 value on the x-axis, a2 value on the y-axis. These are the unit vectors. We'll be seeing unit vectors in detail as well, where we will explain how the unit vectors just represent the direction. What are unit vectors and what is their purpose. Okay, so just as a basic thing, this is I, which is representation for unit vector for the x-axis, and j is for the y-axis. Okay, with a plus in between. All right, this is the representation of a vector. Magnitude. Now if you have a vector, for that vector, how do you find the magnitude? The formula is you write vector A in two lines, in the center of the two lines, which is equal to root of the first value square plus the second value square. So a1 you take from here, you square it, plus you take a2 from here and you put a square, and you take the square root of that. That will give you the magnitude of the vector. All right, then you have the 3D representation. It's the same thing. So you just have the same a1i, you have the x-axis value, you have the y-axis value. Another thing that is added is k, so that's a3k, which is the z-axis value. So in a 3D representation, how do you point out something? You point out with the help of the z plane as well. So not just x and y, you also add in z. Okay, this k is a direction of the unit vector for the z-axis. All right, so you will write a1i plus a2i plus a3i. This is a representation of a vector in a 3D plane. For example, now we have a vector a over here, which is 3i plus 4j. So just remember, this is 3, you have to put the thing here, which is for the unit vector. Okay, so you have 3i, now this is on the x-axis, and 4j on the y-axis. This is the representation of the vector a. All right, you have to find, now this is in which plane? This is in 2D plane. This is a 2D vector because we do not have k here, so it's just 2D. You have to find the magnitude. So magnitude, you will apply the formula. You will take root of 3 square, which is a1, and 4 square, a2, right? So 3 square plus 4 square, which is root of 25, which give you 5. So the magnitude of the vector is 5. It's a very simple manner finding the magnitude of a vector through the formula under root a1 square plus a2 square. If you're talking about 3D vectors, for that, what will be the magnitude? You will just add here plus a3 square. Okay, under root the entire thing, a1 square plus a2 square plus a3 square. All right, that's about magnitude. We'll be doing many exercises so you will be able to understand it clearly. Direction of a vector, the second thing which defines a vector, is a direction. Now the direction indicates where the vector is pointing. It is typically given by as an angle. So in two ways you can tell the direction of a vector. First one is by the angle. As an angle, for example, 45 degrees from the x-axis. So you see on the x-axis it makes an angle theta. Right, this is 45 degrees, so we can say that the direction of the vector is 45 degrees from the x-axis. All right, or as a unit vector in the direction of the vector. So when we were saying that, for example, whatever vector we wrote in the previous one, let's suppose we wrote 3i, right? This I is the unit vector, right? And this unit vector is doing what? It is telling us the direction of the vector, that is this point A1. It is telling the direction of A1. Then we will have plus 4j, right? Now this unit vector is telling us the direction of the point 4, which is on y-axis. When you plot it, you plot 3 on the x-axis, you plot 4 on the y-axis, and you join them, so you get a point. Right, then you will make the vector. So that will be the direction of the vector. So through the help of these unit vectors, you also get the direction of the vector. Right, now this is the formula to find the value of the unit vector, which we will be doing in detail in the future videos. So just as a basic thing, unit vector will be equal to the vector itself divided by the magnitude of it. This is how you find the value of the unit vector. All right, so this is the formula for the unit vector. We will see this in detail later on. Next, we are going to see the direction in two ways. Now, for the magnitude, we know there is just one formula, under root a1 square plus a2 square plus a3 square, right? Now, for finding direction, we just saw there are two ways. First one was by using angle, and second one by using unit vector. We will just see how to do that. So for the angle, if a 2D vector A is equal to a1i plus a2i, the angle theta it makes with the x-axis is. Now this is given by a formula. Instead of, either you make it directly on the Cartesian plane, or you will use the formula. Right? How to use the formula? Now the formula is that angle is equal to, the theta is equal to tan inverse from the vector. So for example, in the question you are given a vector. So let's suppose this is 3i plus 5j, right? Now you have to find the angle it makes with the x-axis. How will you do that? Theta is equal to tan inverse of a2 by a1. So a2 is 5, a1 is 3. That will be tan inverse of 5 by 3. You solve it and you will have the angle, which will give you the direction of the vector, right? For example, again, it's the same thing that I just explained to you. A is equal to 3i plus 3j. So this is a1 and this is a2. So theta is equal to tan inverse of 3 by 3, which is tan inverse of 1, which is equal to 45. All right, that's how you find the direction using angle. Next, you have find the direction using unit vector. The unit vector has a magnitude of 1 and shows the direction of the original vector. Again, you'll be doing this in detail later on. Just for a slight understanding, unit vector will always have a magnitude 1 because unit vectors are specifically used for indicating that direction. Okay, we do not have anything to do with its magnitude, so we take it as 1. We are always going to use unit vectors for finding the direction of a vector. So how do you do that? To find the unit vector A in the direction of the vector A, for any vector A, the unit vector will be A with this symbol on the top, right? A hat on the top. That formula is vector A divided by magnitude of A. So to find the unit vector, what you do, first you have to find the magnitude of A, then you will divide vector A by the magnitude. That will be your unit vector. How do we do that? We see now. Vector A is equal to 6i plus 8j, right? So first you find the magnitude. Root of 6 square plus 8 square, you get 10, right? This is the magnitude. So unit vector will be equal to the vector itself, which is given in the question, divided by the magnitude. So this is where we are applying this formula. So this will be 6i by 10 and plus 8i by 10. This is the value of the unit vector. Alright, which will be 0.6i plus 0.8i. I. That's how you find the unit vector. Okay, you find the direction using angle and you find the direction using unit vector, the two ways of finding direction. All right. Definitely we'll be doing exercises, so make sure you stay tuned for the exercises video. We will be performing these formulas again and again, so it will be on your fingertips. Now we just summarize whatever we did. So we basically talked about a vector, a quantity which has both magnitude and direction. This is important. We have vector is something which has a magnitude and it has a direction, in contrast to a scalar which has only magnitude. Magnitude and direction, the two things about the vector which define the vector. Magnitude is the length of the vector calculating using Pythagoras. So Pythagoras is usually the formula itself that we talked about. That's the formula to find magnitude, is basically the distance formula, right? That we'll also be seeing in one of the exercises as well. The distance formula is itself square root of a1 square plus a2 square. So that is the same formula for magnitude. Direction, orientation of the vector via angle or unit vector. So two ways to find direction. And the unit vector, vector with the magnitude 1, indicates direction only of the given vector. Okay, these are the four things we touched in this video. All right. So that's it for this video. Thanks a lot for staying till the end. We are going to continue with this series of lectures very soon, so make sure you like, share and subscribe to my channel for more exciting content related to pure mathematics and applied mathematics. And in the next video we're going to talk about the next topic, which is the position vector. So that's all for today. Thanks a lot. Stay tuned. Bye bye.